Let's start with something that seems almost too simple to think about: walking forward. We do it every day, thousands of steps in a lifetime, and yet if you really stop to examine it, forward walking is anything but simple. On the surface, it looks effortless, just one foot in front of the other. But underneath, it's a highly coordinated symphony of motion. Your muscles contract and relax in precise timing, your tendons stretch and recoil, your joints rotate along specific angles, and all of it is orchestrated by the nervous system, from your spinal cord to your brain. Even the tiniest adjustments in your ankle or your balance require complex calculations that happen automatically without you thinking about them. Because forward walking is so habitual, our bodies develop what we might call well-worn grooves. Certain muscles fire in predictable sequences, certain joints follow repetitive paths, and our nervous system expects the world to behave a certain way. That's why it looks easy, because it's highly practiced, but that very repetition comes at a cost. Over time, these grooves become rigid. Your muscles can get imbalanced, certain joints may carry more stress than others, and your posture slowly adapts to the path your habits have carved. Imagine walking down a forest trail every day. At first, the path is clear and easy. After years, the same path develops deep ruts, worn edges, and narrow channels. Your feet know the trail, but the trail itself limits your movement, forcing your body into patterns it may not even notice. Even when we think we're relaxed while walking, small misalignments build up. Forward walking strengthens some muscles disproportionately while neglecting others. The quadriceps may dominate, the glutes may underperform, the tiny stabilizing muscles in your feet and ankles may barely engage. Over years, these imbalances manifest as stiffness, minor aches, or a subtle loss of coordination. The nervous system, too, becomes specialized. It predicts motion based on what has worked for decades, but prediction comes with rigidity. Your brain knows exactly how your body will move forward, which is efficient, but that efficiency also makes it less adaptable. And here's the fascinating part. While forward walking is automatic and natural, it can quietly limit the body's potential. The very act we take for granted every day, stepping forward, can be a source of subtle stress, repetitive strain, and muscular imbalance. You could think of it as a kind of hidden wear and tear that accumulates imperceptibly. We rarely notice because the body adapts. Pain or stiffness might never appear, or only show up as tiny inefficiencies in balance, coordination, or posture. The systems involved, muscles, joints, nerves, are so interdependent that the effects of forward walking are not always obvious in isolation. We experience the world through these habitual patterns without realizing that every step forward reinforces them. Walking forward teaches us about predictability, efficiency, and habit. It shows how the human body thrives on repetition and routine, but it also teaches us about limitation, about how patterns, once formed, can become too rigid, too specialized, too narrow. The very motion that allows us to explore the world can also constrain us. That tension between freedom and constraint, between habitual motion and hidden imbalance, sets the stage for something surprising. A simple reversal of direction can produce effects that feel almost magical. Walking backward challenges all these established patterns, activating muscles, joints, and neural pathways in ways forward walking never does. Now, imagine turning around and walking backward. At first it feels strange, awkward, even a little uncomfortable. Your feet don't quite know where to go, your balance feels uncertain, and your brain has to work overtime just to make sense of the motion. Yet almost immediately, something remarkable begins to happen. Muscles you rarely use while walking forward suddenly engage. Your quadriceps, calves, glutes, and even muscles along your spine fire in new patterns. Joints move in ways that forward walking doesn't demand, and your posture adjusts as your body searches for stability. It's as if walking backward forces your body to awaken parts of itself that have been dormant, creating an entirely new rhythm and balance. The change is not only physical but neurological. When you walk forward, your brain predicts each step, relying on decades of learned patterns. Forward walking is automatic. The brain can relax because it already knows what comes next. Backward walking shatters that predictability. Your brain can no longer rely on old assumptions. Every step is uncertain, every balance adjustment has to be calculated in real time. This forces your nervous system to explore new pathways, recruit different neurons, and coordinate muscles in a fresh way. It's a rare opportunity for the brain and body to experience novelty while performing a familiar action. There's a useful analogy here. Think of your forward walking patterns as a city's main roads, wide highways used by everyone. They're efficient, fast, and familiar. Now, backward walking forces you off the highways and into narrow side streets, alleys, and hidden paths. Traffic redistributes, new connections emerge, and the city starts functioning differently. In your body, the same thing happens. Muscle coordination, joint movement, and neural activity all redistribute in ways that forward walking suppresses. This redistribution often feels like a reset. Tension melts, posture improves, balance stabilizes, and even the mind can feel sharper, more alert, and more engaged. Walking backward also seems to correct imbalances that forward walking has reinforced. Muscles that were underused begin to strengthen, overused muscles are relieved, and the nervous system recalibrates. For people recovering from injury or working to improve mobility, backward walking can stimulate progress in ways forward walking cannot. It provides a safe, low-impact challenge that engages the body in its entirety rather than emphasizing certain habitual patterns. Even the act of seeing the world in reverse, literally moving into spaces you normally leave behind, changes perception. The brain integrates visual, spatial, and motor feedback differently, encouraging adaptability and balance. What's most fascinating is that this effect is both measurable and elusive. Scientists can record muscle activation, brain scans, and joint movements, and they see clear differences between forward and backward walking. Yet the subjective feeling, the sense of looseness, the subtle relief, the aha sensation in posture or coordination remains mysterious. The mechanisms are partially understood, but not fully. Walking backward taps into complex interactions between body and mind, revealing hidden capabilities that forward walking alone cannot access. It is a small but profound example of how simple changes in behavior can produce unexpectedly large effects in complex systems. Walking backward, in this sense, is not just a physical act, it is an experiment in resetting habitual patterns, in discovering flexibility within rigidity. It reminds us that our bodies and brains are not fixed. They are dynamic, adaptable, and capable of surprising transformations when given a different perspective. And the more you explore it, the more you realize that what feels awkward or unnatural at first may actually be the key to restoring balance that forward walking, for all its familiarity, has slowly broken. Scientists have started to study backward walking mostly in the context of rehabilitation, physical therapy, and neuroscience, and what they've found is fascinating. On a purely mechanical level, backward walking strengthens muscles differently than forward walking. The quadriceps, for example, take on more of the load, while the hamstrings and calves also engage in ways that forward walking tends to bypass. This can relieve stress on joints like the knees and hips, which are often overloaded by repetitive forward motion. But the story doesn't stop with muscles and joints. The nervous system itself is actively involved in recalibrating balance and coordination. When you walk backward, your brain is essentially being forced to learn a new motor skill in real time. It can no longer rely on the ingrained predictions that forward walking allows. This means it engages different circuits in the cerebellum, the part of the brain responsible for movement precision, and in the motor cortex, which plans and executes voluntary movement. Even the hippocampus, which helps with spatial awareness and memory, is more active because backward walking challenges your sense of direction and forces you to navigate without the usual visual and proprioceptive cues. In a sense, every step backward is like a mini exercise in brain plasticity, nudging neurons to form new connections and reorganize existing ones. Yet, despite what we can measure, there is a strange mystery. Forward walking creates habits that the body seems to prefer, while backward walking produces effects that feel restorative, almost like pressing a reset button. Researchers can observe muscle activation, brain scans, and joint kinematics, but they still struggle to fully explain why backward walking feels so different on a subjective level. The subtle sense of looseness, the sudden awareness of balance, the feeling that something clicks in your body, these cannot be fully captured by numbers and graphs. This is a perfect illustration of the gap between observable data and lived experience, and it's one reason humans have such a hard time explaining it. There's also the question of coordination. Walking backward forces your body to break free from habitual sequencing. Your gait is slower, your steps more deliberate, your posture slightly different, and your visual and spatial processing has to adjust. This recalibration involves countless micro adjustments, tiny rotations in your ankles, shifts in hip alignment, subtle changes in muscle tension. Each of these adjustments is coordinated by the nervous system in ways we don't fully understand. It is a deeply complex, adaptive system where small changes produce ripple effects. Even the simplest backward step is a coordination challenge that stimulates the brain and body far more than forward walking. Another layer of mystery comes from the psychological effect. Humans are pattern-seeking creatures. We crave predictability because it conserves energy and reduces cognitive load. Forward walking is familiar, automatic, and comfortable. Backward walking violates that expectation. It creates a controlled uncertainty that forces attention, engagement, and curiosity. The body and brain respond by activating underused systems, reorganizing movement patterns, and even improving mental alertness. This explains why therapists sometimes prescribe backward walking for patients recovering from strokes, injuries, or neurological disorders. It challenges both mind and body, encouraging recovery and adaptation in ways forward walking does not. In short, backward walking is more than just a quirky alternative. It reveals fundamental truths about how humans move, how our nervous system learns, and how the body maintains balance. It also exposes the limits of our understanding. Even with advanced tools, we cannot fully quantify the subtle, restorative, and sometimes mysterious effects it produces. It's a reminder that our bodies are not simple machines, but dynamic adaptive systems capable of surprising transformations when we step off the familiar path. Let's play with a simple thought experiment. Close your eyes and picture yourself walking down a familiar path, the kind you take every day. Your steps are automatic, your balance is predictable, your muscles fire in a rhythm you barely notice. Now imagine reversing direction. You start walking backward along the same path. At first, your feet stumble, your posture feels strange, and your mind struggles to keep up. Every step requires attention. Every motion demands recalculation. Suddenly, the familiar becomes unfamiliar. The predictable patterns that forward walking reinforced are disrupted, and your body and brain are forced to find new solutions. What's happening here is profound. Walking backward engages different muscles, joints, and neural circuits, but it also forces the mind to confront uncertainty in a controlled, safe environment. Forward walking relies on prediction, on a kind of automation that conserves energy and reduces mental effort. Backward walking violates those predictions. The brain must process new sensory inputs, reassess spatial orientation, and coordinate movements that it has rarely practiced. In effect, it creates a mini laboratory inside your own body, where new connections are formed, old tensions are released, and subtle imbalances are corrected. Imagine your body as a complex network of roads. Forward walking follows the main highways, the well-paved routes used day after day. These routes are efficient but narrow, and traffic is constrained by the predictable flow. Backward walking forces you onto secondary roads, alleyways, and hidden paths. Suddenly, traffic is redistributed, side streets are explored, and parts of the city you never knew exist come to life. Your muscles, joints, and nervous system experience movement in ways that forward walking suppresses, revealing hidden flexibility and balance. The small, unfamiliar steps backward act like a gentle shock to the system, jolting it out of habitual patterns and prompting adaptation. Now consider the broader implications. This thought experiment is not limited to walking. It illustrates a principle of human physiology and cognition. Sometimes, the way forward is not forward at all. When patterns become too ingrained, when repetition has produced rigidity, the path to restoration may involve reversal, disruption, or reconsideration. Backward walking is a literal demonstration of this principle, a small, deliberate disruption that triggers reorganization and renewal. It is a reminder that the body and brain are not linear systems. Small changes can cascade into large effects, and novelty can catalyze adaptation in ways predictability cannot. Even more intriguingly, backward walking creates a direct connection between physical action and mental experience. The brain responds to uncertainty by engaging attention, curiosity, and problem solving. Balance improves, posture adjusts, and muscles that have been neglected for years are suddenly activated. You become more aware of your body, your environment, and the subtle interactions between the two. What forward walking conceals through routine, backward walking reveals through novelty. It is a paradox. The more we attempt to move efficiently, the more our body can become stuck in its own patterns. The more we intentionally introduce uncertainty, the more our system adapts, corrects, and heals itself. This is why backward walking feels so restorative, almost magical. It's not magic at all. It's a window into the dynamics of complex systems. Muscles, joints, nerves, and the mind working together, responding to new stimuli and finding equilibrium in ways that cannot be reduced to simple cause and effect. It teaches us a subtle but powerful lesson. Sometimes, the way to fix what is broken is not to push forward harder, but to step backward, to disrupt the familiar, and to explore the hidden paths that have always been there, waiting to be discovered. Humans have a deep instinct to understand the world in simple, linear ways. We like neat cause and effect stories. Step A leads to result B. Forward walking seems like that kind of story. Lift a foot, move it forward, shift your weight, repeat. It looks straightforward, predictable, and easy to explain. But backward walking exposes the limits of that kind of thinking. Suddenly, the simple story doesn't work anymore. Step A doesn't just produce result B. It produces a cascade of changes across muscles, joints, nerves, and perception, and some of those changes are subtle, subjective, and difficult to measure. This is why humans struggle to explain it. The systems involved are complex, adaptive, and highly interconnected. Our bodies are not machines with a single linear pathway from input to output. They are dynamic networks. A small shift in one area, a slight change in gait, a tiny reallocation of muscle effort can ripple across the entire system. Muscles compensate, joints adjust, the brain recalibrates balance, and even mental awareness subtly shifts. Forward walking creates entrenched patterns, backward walking disrupts them. But because the changes are distributed across multiple levels of the body-brain system, isolating a single cause is almost impossible. One researcher might see improved quadriceps strength, another might see altered neural activity in the cerebellum, and yet another might notice a subjective sense of looseness or balance. All are correct, and none fully explains the phenomenon. This is the essence of why it's so difficult to put into words. Backward walking interacts with our physiology, neurology, and psychology in ways that resist simple categorization. Each person's experience is slightly different because each body has its own history of movement, its own habitual patterns, its own neural wiring. What feels restorative to one person might feel awkward to another, yet the underlying principle remains the same. Novelty disrupts habit, uncertainty triggers adaptation, and balance emerges from exploration rather than repetition. It's also a lesson about humility and science. We often assume that if we measure enough variables, we can explain everything. But some phenomena, especially those that are holistic and systemic, refuse to be fully reduced. Backward walking is one of these phenomena. We can measure muscle activation, brain activity, joint angles, and balance responses, and we can learn a lot. But the feeling of being reset, the subtle coordination that emerges, the sense of surprise and novelty in an otherwise familiar environment, these are more than the sum of measurable parts. They remind us that complex systems, including our own bodies, contain emergent properties that cannot always be predicted or neatly explained. Perhaps this is why backward walking is so compelling. It confronts us with the limits of our assumptions. It shows that mastery is not just about repetition and efficiency, but also about flexibility, exploration, and adaptation. It teaches that our bodies and brains are capable of recalibration, and that sometimes the best way to restore balance is to deliberately step out of the habitual, to create small disruptions that ripple across the system in ways we cannot fully control or predict. In a sense, it's a metaphor for learning, problem solving, and life itself. The most profound insights often come when we reverse direction, challenge expectations, and open ourselves to new patterns of connection. Backward walking, then, is not just a physical exercise, it is a window into complexity, adaptation, and the subtle interplay between order and uncertainty. It is a reminder that the systems we inhabit, our bodies, our minds, even our perceptions of the world, are never fully predictable, never entirely linear, and always capable of surprising transformation. And it is in this space of uncertainty, curiosity, and exploration that true understanding begins. So, what does all of this teach us about reality, about our bodies, and about our minds? Walking backward is not just a physical act, it is a profound illustration of how the universe often works in subtle, nonlinear ways. Forward motion breaks patterns, creates efficiency, and builds familiarity, but it also creates rigidity. Backward motion disrupts those patterns, engages neglected systems, and restores flexibility. This simple act reveals a deeper truth. The world is rarely linear, predictable, or fully comprehensible, and the systems we inhabit, our bodies, our brains, our habits, are far more adaptive and surprising than we normally realize. Think about it. We often assume that progress, recovery, or understanding comes from moving forward, from repetition, from building upon what is already known. But backward walking shows the opposite can be true. Sometimes, to regain balance, to release tension, or to discover something hidden, we need to reverse course, even if only slightly. Small, deliberate reversals can ripple across the system, producing effects that are disproportionate to the effort. A single backward step engages muscles differently, rewires neural pathways, and challenges habitual perception. It is a vivid example of how minor interventions can yield outsized impact in complex adaptive systems. The implications extend beyond walking. Life itself is full of entrenched patterns, habits, assumptions, routines, and ways of thinking that are efficient but limiting. Often, the only way to gain new insight, solve a problem, or restore equilibrium is to deliberately step into uncertainty, to explore alternative paths, or to temporarily reverse course. Backward walking is a literal physical metaphor for this principle. It demonstrates that novelty, disruption, and even discomfort can be essential ingredients for growth, adaptation, and discovery. What is most striking is the humility it teaches us. We like to believe that with enough observation, calculation, and effort, every system can be fully understood and controlled. Yet backward walking reminds us that some effects are emergent. They arise from countless interactions among muscles, joints, nerves, and the brain, and cannot be fully reduced to simple cause and effect formulas. The subjective feeling of balance, looseness, or restoration cannot be completely measured, even as it is very real. Reality, it seems, is always richer than our models, and our experience often contains layers that science can describe but not entirely capture. In a way, backward walking invites us into curiosity. It asks us to pay attention, to notice patterns we usually ignore, to explore the hidden potential in systems we think we already understand. It encourages us to accept uncertainty as a doorway rather than a barrier, and it reminds us that adaptation is not always forward. It can be lateral, counterintuitive, or even backward. Perhaps the most profound insight is this: reality is not strictly about moving forward, about efficiency, or about predictability. It is about interaction, exploration, and the constant reorganization of systems in response to novelty. Walking backward is a simple act that illuminates this principle in the most immediate physical way. It shows that our bodies, our minds, and the world itself are dynamic, responsive, and capable of transformation when we allow ourselves to step off the habitual path. The next time you walk, try reversing your steps. Notice the subtle shifts in your muscles, your balance, and your awareness. You may feel awkward, uncertain, or out of rhythm at first, and yet in those backward steps, you are touching a fundamental truth. The universe is not always linear, and sometimes the key to restoring balance and discovering new insight is not to move forward, but to step backward, even for a moment, and let the hidden potential of the system reveal itself. There's another layer to consider: the way backward walking teaches us about the interplay between perception, action, and awareness. When we walk forward, the world appears predictable. Our eyes, ears, muscles, and brain have formed a seamless loop of expectation and execution. We see a path, we step, and our body responds almost automatically. But backward walking disrupts that loop. Suddenly, vision is less reliable because you are moving into areas you haven't directly observed. Proprioception, the body's sense of position and movement, takes over in new ways. Muscles and joints communicate information to the brain that is unfamiliar. Your mind is suddenly alert, engaged, and curious. This is the paradox. Limitation creates possibility. By stepping into uncertainty, by creating a situation the body and mind are not accustomed to, you allow new capacities to emerge. This principle is not confined to walking. It can be applied to learning, problem solving, and even creativity. In any system, whether it is a machine, an ecosystem, or a human brain, habitual patterns dominate. They are efficient, comfortable, and familiar, but they also suppress novelty and adaptation. Introducing controlled perturbations, small challenges or reversals, forces the system to reorganize. It tests flexibility, activates unused potential, and encourages new connections. Backward walking is a literal, physical embodiment of this principle. By moving against expectation, we force both body and brain to explore alternative strategies, revealing capacities that are otherwise hidden beneath the routine of daily life. There is also a profound temporal element. Forward walking carries the symbolism of progress, of linear time, of moving from past to future. Backward walking, by contrast, introduces a form of temporal reflection. It is not literal time travel, of course, but it engages our attention in a way that emphasizes process over destination. Each backward step requires presence, awareness, and recalibration. The act itself becomes a meditation on motion, on feedback, and on how small changes propagate across a system. It teaches patience and observation, because the body cannot rely on ingrained assumptions. The experience is subtle, yet transformative. Muscles awaken that were dormant, joints adjust, balance improves, and neural circuits are recruited in ways that forward motion alone cannot achieve. The subjective sense of restoration, the feeling that something is reset, is not just physical, it is a demonstration of a larger principle. Complex systems thrive on novelty and disruption. The body is a network, the brain is a network, and both are capable of reorganization when challenged in the right way. These are lessons that apply far beyond walking. They speak to how we approach learning, adaptation, and problem solving in every domain of life. Perhaps the most striking takeaway is humility. We are accustomed to thinking that with enough knowledge, control, or repetition, we can master any system. Yet backward walking reminds us that mastery is not only about predictability, it is about responsiveness, adaptability, and awareness. Even a simple act, like reversing direction, can illuminate the limits of our assumptions and open up new possibilities. It is a lesson in curiosity, in experimentation, and in paying attention to the subtle ways systems, ourselves included, respond to change. In this light, walking backward is more than exercise. It is a demonstration of a fundamental principle of reality. Systems are dynamic, emergent, and deeply sensitive to small shifts. What seems awkward, unnatural, or counterintuitive can be precisely what triggers adaptation and insight. By stepping backward, even for a moment, we engage with the world in a new way. We witness the hidden potential within ourselves and the systems we inhabit, and we are reminded that the universe, like the human body, is always more complex, more flexible, and more